Hello everyone, thanks for coming. I don't know if you're an early bird or the jet lag like me forced me to come down here early. So thanks for coming, it means a lot to us. Just in case you're in the right place, this is the open source session, the Pragmatic Serverless Python Developer. So either you like open source or Python the best language in the world or something else, so thanks for coming again. I'm Metro Lassa, I'm a chief architect for Power Tools for AWS. Tool that we're going to see later. And with me, I have my friend Run from CyberArk, which he'll present soon enough. Let me walk you through on what we've got. So this is the agenda we have today. We want to walk you through and explain to you what pragmatism actually is in the first place. And then to apply this pragmatism, this idea of making decisions, we thought a use case would be better. So we applied this into multiple cases. And in this use case, we're going to use a synchronous part, which is a product API. And then we're going to use a asynchronous part to show you how the initial ideas that look good will look terrible if you do it in async fashion and how we have to change. And then lastly, we look into some of the tools you could use for production as you go to production with this or something similar. And the ones that we're going to show you are handling roughly 50 billion transactions a week. So it should be production ready for most of you. And then we wrap up as usual. When it comes to pragmatism, what we're trying to mean in this entire session is decisions that you're about to make, whether you're in a project alone or in a team, the skills that you have or the tools you're going to use, all of this matter. Someone could tell you that these are the best practices and this is the only way to do things, but they might make sense to you in the team you have or the setting that you have. So taking context into account is important. So that's what we're going to use this in this session here. When you start on your first project, you might be thinking, should I use SAM as my infrastructure as code framework? Should I use CDK? Should I use Amplify? Or maybe Bash scripts? They could also work. Depends on what you're trying to work on, the context you have. And should I use a single function for everything or multiple micro functions in there? Should I use domain-driven design or something else entirely? Maybe I don't need any of these things in the first place. As you answer these questions, other questions will pop up. Should I do synchronous API? Should I do asynchronous from the get-go? Should I use open source tools? And so which should I use? How do I even test for something that's asynchronous? That's something that's going to go across the border of my boundary of my service. So these questions are common. And typically you get into this analysis paralysis that you don't really know what decisions you got to make. And this session is about coming some of this for you and trying to make a framework so you can make those decisions easier. We're going to cover the open source tools and some of the leading practices and what we typically learn from open source that we can apply in our projects. For this session, there's so many open source tools that will be hard to cover all of them, so we're going to be focused on these 4. If you've never heard of them, Make Docs Material is the engine that drives the documentation, that makes writing documentation fun, actually. It's something we use for Power Tools for the last nearly 4 years. And PyTest is to run your tests that we write, unit integrations, end-to-end, which we'll show you. Pydantic is what makes it easier for us to do data validation and defining our models on what our data should look like and so forth. And Power Tools for AWS Lambda, I hope you're using it, is the framework that makes all these best practices easier and improves your developer experience. But I would be remiss if I didn't tell you that there's so much more that I wish we could cover in this session. These are just some of what we're using it. And at the end of the session, we're going to give you the project itself and a treat at the end of it as well. If you stay long enough, hopefully you will. What can we learn from open source, though? All of these open source tools typically have something similar to this. When you're trying to deploy something on GitHub or Bitbucket, you name it, in there, you typically have all these phases. Someone has to set up your project for the first time. Imagine you're onboarding someone for your project. They have to know how to check out the code, virtual environments, how do I find dependencies, and so forth. And then eventually, in those pre-commit hooks, which is a fantastic open source framework called pre-commit that saves you from a lot of trouble. Imagine open source, you have people from all sorts of skills trying to make contributions. So you've got to have some baseline to allow them to make those contributions more easily. So pre-commit checks can easily check from anything, from security, potential leaking credentials, to incorrect files, or basically not even meeting governance, for instance. And then when it comes to before you make a pull request, there's even more checks in there, and they have documentation linting. Most of us eventually end up pushing some documentation that's broken. The links don't work, or something that doesn't really fit into the message that we're trying to say. And then lastly, we have the pull request checks. We have governance, which we do in this project, in the Power Tools as well. And you have security checks that you might want to run on your dependencies or whatnot. No matter which project you see that's popular and open source, they all will have something, at least like this. In Power Tools, we go just over 20,000 CI runs a week to give an idea of how important these things are. Every time someone makes a commit or code or open a pull request, we run through this, going to thousands of this a week. But when it comes to pragmatism for us, this is something you can copy and paste. We work for everyone, but this will not. If you have to test something, how to run your tests, whether you run the test only for files that have changed, or you run unit tests, integration tests, and so forth, these are different. You gotta have some application to be able to run these things. Otherwise, there's nothing really for us to talk. So this session, we're gonna go through this in more details, how you can run these things. So let's get to the use case first. We wanted something that isn't a hello world, but isn't something too complex that you wouldn't be able to understand in 1 hour, or everything about it in 1 hour. So imagine you have a product API that you add products, delete products, and so forth. You gotta use a database, and then eventually whatever you added, you emit an event. So if you're using AWS terms, we're gonna have API gateway with a bunch of functions that handle all these operations, create, add, delete, and so forth. The database, we're gonna be using DynamoDB as our NoSQL managed solution. And the asynchronous part, we're gonna be using a mix of batch processing and event bridge to emit these events. The idea for this is that this part on the left is what most people typically go through. You have a synchronous flow, you send a request, you wait for a response, good to go. The asynchronous part is a bit difficult when you think about testing. If you make an API call to the first API gateway and wait for the response, you tested, looks good. But how do you test it goes all the way through now that an event was emitted and everything else? It's a bit different. But let me allow you to run, to go through the first part, and I'll come back into the streaming.
Thank you, Heider. Hi, everybody. My name is Ron Eisenberg. I'm a principal software architect at CyberArk at the Platform Engineering Group at AWS Serverless Hero, and the owner and the maintainer of the website ronthebuilder.cloud, where I talk about everything AWS and serverless in general. Right. So we're going to focus on the products API, the synchronous part of the service, the API gateway, the Lambda functions, and the DynamoDB table. We're going to dissect it into several practices. The project practice, we're going to talk about project structure, infra as code, the Lambda handler, how do we write the Lambda handler, how do we write the business domain code, how do we write the integration code, the code that interacts with AWS resources, and how do we test it all, the unit test, the integration tests, and end-to-end tests. So first of all, the way I see it, a serverless service is a synergy between 4 elements: the infrastructure as code, the domain code, the tests, and the production readiness elements. Now, the infrastructure as code is basically the resources that we deploy to the cloud, the API gateway, DynamoDB table, and the Lambda functions. Now, the Lambda functions, they hold and contain the business domain code. The business domain code, on the other hand, it interacts with the resources that we deploy, such as the DynamoDB table. In the test section, in the test elements, we're going to test basically both the infrastructure as code, the API gateway, and our business domain code. And the production readiness elements, well, they're pretty much spread across all the other elements. In the infrastructure as code, the production elements are manifested as configuration for scale, security, backups, things like that. In the domain code, it is manifested as input validation, authentication checks, authorization checks. And in the testing, you might probably have testing for security. So as you can see, everything is basically connected together. Now, I've been advocating for DevOps culture for a very long time now. And the way I see it, developers, they need to own these elements from the development stages all the way to production. It makes them basically more independent, and it enables them to deploy much faster to production. Now, in order for all these synergy to occur, you need all the elements to reside in the same project structure. So that's what we're going to talk in a second. We're going to present you an opinionated version of the project structure. Okay, so first of all, we're going to have a product folder. That's basically the folder that's going to hold our business domain code. Product is the name of our service. We're going to have a subfolder CRUD for the domain, our CRUD API. And then we're going to have the handlers for the business domain code and schemas. Schemas is very important. It's basically the Pydantic models that we're going to use for Pydantic is an open source utility that allows you to do input validation and parsing, so we're going to basically contain all the models there. We're going to have a testing folder, so end-to-end integration unit. And like I said before, all the production readiness elements are going to be spread across the other folders. And we're going to have a PyProject TOML file. Now, we chose Poetry over pip because we think it's much faster. And we're going to basically manage all the dependencies, both the infrastructure as code and the business domain code in one file. Now, I've seen people use multiple files to hold the dependencies, usually multiple files per Lambda handler. And while that is possible, I think it makes things more complicated. As we're going to see later on in the testing, we want to have a local environment to set up it much easier. So having one file is just simple. So keep it simple, just one file. And lastly, we're going to have a folder for the infrastructure as code. So you can choose either CDK, SAM, Terraform, whatever you want to choose. But we chose CDK. I love CDK. I have loved it for a long time. And we're going to use one CDK application, app.py, one stack, service stack.py, and we're going to have one construct, a domain-driven approach to building our CDK construct. So one construct, the CRUD API construct, is going to build for us the API gateway, the Lambda functions, and all the anomaly table, and all the resources that are required to make everything work together. So now that we understand that, let's talk about writing our first Lambda function. Let's say that we want to write the create product Lambda function. We're going to implement the HTTP put/product interface. It's going to save the product into the DynamoDB table. And now comes the question, what is the best way to write a Lambda function? Is there a best way to do that? So back in the day when I started to write serverless services, what I did is basically write everything in the handler itself. So it looks something like this. Just one file, handler create product. And first of all, you're going to do some input validation. So I'm using PowerTools, the amazing PowerTools library. I'm going to use the parser utility to do input validation in conjunction with Pydantic. So I'm going to define the create product request model. I'm going to get the input. Then I'm going to use Boto to basically put the item, the product that I want to insert from the input, to the table. And then I'm going to return the response back to the caller and serialize it. And this is how the code looks all together. And as you can see, it's very simple, right? From the beginning to end, very simple. But is it the best way, though, right? So as with everything in life, context is what matters. So if this were a cron job, a nightly batch job, sure, that's perfectly fine. It's not going to change that often. You can write it like that. It's perfectly fine. But we're running a service, a REST API service with logic, and it's going to evolve over time. And as you can see, our service is now evolved, and now we're required to write 3 more Lambda functions: the get products, get product, and delete product. Now let's say that we're going to write it in the same way, right? We're going to write everything in the handlers. So now we have 4 models, 4 separate models. They're not sharing any code. But now we have new problems. So we have code duplication. Again, it's not sharing any code. 4 different models. Testing becomes much harder because we're doing basically the same 4 times. And in some cases, we might even have code readability issues because some handlers are maybe more than 300 lines. For me, that's a magic number that tells me, Ron, if you have more than 300 lines, you should probably refactor it and make some changes. So as you can see, this does not scale. So can we do better? Yes, we can. Introducing architectural layers, which is a fancy term that architects love, but I promise you it's going to make sense in a second. So we're going to take our handler. We're going to split it into 2. We're going to have the handler layer, and we're going to have the domain layer. The handler layer is going to be basically 0 domain code, and it's going to have very clear responsibilities. The domain layer is going to be where we have all the business domain logic and the other 3 calls, and it's going to be shared across multiple handlers. And we're going to have isolated tests, which also solves a problem that we saw before. So the handler, what is it going to do? It's going to parse configuration, either dynamic or static. It's going to parse and validate environment variables. It's going to do input validation, authentication checks, authorization. It's going to pass the input to the domain layer. It's going to get back a response, and it's going to serialize it back to the caller. And this is from a high-level overview. You have the API gateway, invokes our Lambda function. The handler does its thing, passes the input to the domain layer. The domain layer accesses the DynamoDB table, returns back the output, and the handler serializes it back to the caller. So let's write some code. So our handler is not going to change that much, but still we're going to do the input validation as before. But now, instead of doing the Boto3 call, we're going to call a function in the domain layer. It's called createProduct. We're going to pass it a pydantic model of the product that we want to basically save in the database. We're going to get back a response, and we're going to serialize it as before back to the caller. And this is all the code together. As you can see, it's very short, very clear, 0 domain code. Now, as for the domain layer, so now we need to implement a new function, the createProduct function. So I chose a functional way to do that, but you can also do it with object-oriented and implement it with interfaces and classes. For this, I don't think it really makes a difference, so it's a matter of style. So we're gonna build the product entry, which again is a pydantic model that simulates, represents what we have in the database itself. And then you're gonna see the same Boto3 code as before. We're gonna save it into the database, and we're gonna return the response back to the handler layer. Now, we're gonna need to have more functions like this, right? We need to have the getProduct, listProduct, and deleteProduct interface functions. And as you can see, this is the only place that it's gonna basically access the DynamoDB table. Right, now let's talk about integration practice. What is integration practice? What does it mean? So in our example, integration is basically any code that accesses the DynamoDB table. And in more general terms, it's basically any code that interacts with AWS resources or calls an external API. Now, if you recall from just a second ago, this is our domain layer, and it has basically integration code, right? It has a Boto3 code into it, written into it. So is it OK, though? Right? Can it backfire? So as before, it really depends. So I'm going to show you a use case that happened to my team where it did make a difference. So over the time, we started with DynamoDB table. We had a schema. Everything was working fine. Over time, we had new requirements from the product team to add more and more advanced queries, and our schema just didn't match. And we ran queries, and it just took too long, and the queries were too slow. At some point, we realized that the solution would be to basically replace the DynamoDB table with an Amazon Aurora database. Now, since the integration code was pretty much hard-coded into the domain layer, it was really hard to refactor it out and switch to Aurora database. And we didn't have specific testing for that database section. So as before, can we do better? Yes, we can. Introducing, again, another architectural layer. Surprise. So we're still going to have the handler layer. It will remain basically the same. We're going to have the domain layer, but now it's going to have 0 integration code. And we're going to have a new integration layer. It's going to basically implement an adapter pattern. It's going to adapt whatever logic we have into a concrete implementation of a database. And this is the only place where you're going to have any API code or database code. OK, so again, in high-level overview, you have API gateway, invokes the handler does this thing, passes the input to the domain layer calls the interface function of the integration layer. The integration layer accesses the DynamoDB table, returns back the output. The domain layer converts the output to whatever the output the handler requires, and the handler serializes it back to the caller. So let's write it. Let's write the interface. We're going to create the DB handler interface, and we're going to have a function for all our needs. So createProduct, listProducts, deleteProduct, and getProduct. And now we're going to write an implementation. So now let's write the DynamoDB handler implementation. So it's going to inherit from the DB handler class, and we're going to move our Boto3 code into the createProduct function. So as you can see, this is basically the only class that's going to access our DynamoDB table, and now we can have isolated testing, which is something that we really needed. Now, let's say that we want to switch and write the new Aurora handler instead. So all we need to do is basically write a new class, inherit from the DB handler, and implement all the functions. And then we need to make the switch in the domain layer, right? The domain layer needs to call the new Aurora handler instead of the DynamoDB handler. So let's see how we can do that. So we're going to refactor our domain layer. So as you can see, there's no more Boto3 code here. Instead, you have a getDB handler function, a getter. And we're going to get a concrete implementation, the DB handler, and we're going to call the createProduct function. Now, the domain layer doesn't really care what implementation it is, and it doesn't even know. All it cares about is that it has the createProduct function. Now, if we were to make a switch, all we need to do now is basically change implementation of getDB handler from DynamoDB to the Aurora handler. That's it, very simple. Now that we understand how to build the project structure, write the handlers on all the layers, let's talk about testing. So as you know, serverless testing is not easy. But for me, what guides me is a very specific developer experience that I aim for. And that's basically not to never leave the IDE. I want to work in the IDE as much as possible. I want to locally debug my Lambda functions, to have breakpoints in my IDE. And most importantly, I want to work with real cloud resources. Let me stress that again, real cloud resources. Because if you work with real cloud resources, you can gain more confidence that the code actually works, right? I don't want to work with mocks. I want to work with the real thing. So we're going to cover the testing pyramid, the serverless testing pyramid. We're going to start at the bottom, unit tests. So unit tests are quick. They require no deployment of your service, and you can run them locally in your IDE. So it's going to be something like this. You're going to use PyTest. You're going to prepare the test data, run the tests, and run some assertions. So this is an example of one of the tests that we have. We're going to build tests for Pydantic schemas. We have lots of Pydantic schemas, as you saw. And the createProduct body, that's basically the input model that we have for the createProduct function and handler. So we want to make sure that if we get to create a product, right, if we get an input with an invalid name, an empty name, we're going to get a validation error. And this is basically what the test does. Now, another use case for unit test is where you have a very specific class that takes very specific input, returns you a very specific output, and does not require any resources in the cloud. So you can use that to really make sure that your logic there works properly. Now let's talk about integration tests. And these are going to be pretty much the majority of your tests in your project. Now, they require you to deploy your stack to the service, to the cloud, because you're going to run locally in the IDE, but you're going to access cloud resources. That's why you need to deploy it first. So the way it's going to work, we're going to use PyTest. We're going to generate our test data. In this case, it's going to be an API gateway input, the envelope that it's going to send to our handler, the way it expects it in the cloud. And we're going to send it a context object, same way it's going to get it in the cloud. And then we're going to work in the IDE at breakpoints, and we're going to access our DynamoDB table, which is the resource in the cloud that we have here. Then we're going to verify it and run some assertions. So first of all, we need to generate the API gateway event. So you see I have a function. It returns a dictionary with all the metadata that you're going to get. And in line 7, you have the body of the business payload that you're going to send, the customer is going to send us. So this really makes it easy to run a repeatable testing. And you might ask yourself, well, how did you find this dictionary? Where did you get the definition from? So we have several options. First of all, you can simulate the events and print them and get them from Cloud with logs. Or you can use Power Tools for AWS Lambda. That's what I did, actually. And they have test JSON files for multiple services, so you can take the examples from there and just make the changes. Or you can refer to the AWS service documentation where they tell you this is how the event looks like. So let's write a test. We're going to write the integration test for the createProduct handler. So we're going to generate the event in line 2. And then we're going to call our Lambda function entry point in the IDE, which I call Lambda handler. I know, very original. We're going to pass the event, and then we're going to pass the context. Then you can add breakpoints in the IDE. You're going to work against the cloud. You're going to access the DynamoDB table. You're going to get the response back, and then you're going to assert the response. So we want to make sure that we have status code 200 OK, and we want to check any side effects. Now, our create product function saves the product to the database. So what we want to check that an entry is actually inserted to the database with the correct values. So that's what we're going to do. We're going to use Boto to basically fetch the item and see that all the values match up. And this is all the test all together. I think this is a great way to do TDD. That's usually how I develop new Lambda handlers. So I would write an empty skeleton for a Lambda handler, and I would write the test, and I would use the test to basically debug my function and start to implement it until the test passes. Now, there are some cases where you want to simulate some failures. In our case, we want to make sure that if we have a put item failure, right, it can fail sometimes, we want to see that our handler returns a 500 response code. So I use Stubber from Boto Core to basically simulate the failure. And this is how it looks like. Now, you might ask yourself, well, you're not using any cloud resources in this case, so why did you write it as an integration test? Why not unit test? And to be honest, you do have some point here. But from my experience, the more the service becomes more complicated, you have more and more cloud resources that you interact with. So you might have at the beginning some app config configuration that you loads, maybe SSM parameter store parameter or a secrets manager secret. So now if you write it as a unit test, you need to also start to mock all the other resources. So you spend more time to mock resources instead of just focusing on the test. So for me, a better developer experience is to mock only what I want to fail and to work against the cloud and let the other resources just load from the cloud. Lastly, we're going to talk about end-to-end tests. Again, these tests, they require deployment to the cloud, but they're going to run specifically on the cloud and not on your IDE. Now, you might ask, well, Ran, you're already working against the cloud in the integration test, so why do you need the end-to-end tests? So the reason is that I need them because the Lambda functions, when they run in the cloud, they run a bit differently, right? They have their own role with different permissions. You might have misconfigured the environment variables or other configurations. So in order to make really sure that it works, even though your integration tests work locally, you need to make sure that also the end-to-end tests are properly, they work properly, so everything is configured properly in the cloud. And this is how it's going to look. You're going to use PyTest to generate any taste data. And we're going to simulate the same input that any customer is going to use our API. We're going to call our API gateway in the cloud. It's going to invoke our Lambda function. And then we're going to run some assertions on the response that we get back. So let's write the end-to-end test for the create product function, Lambda handler. So we're going to generate in line 2 our body for the requests open source library. We're going to call the put product API. We're going to pass the input. Again, it's going to trigger the API gateway. It's going to run on AWS 100%. And we're going to run some assertions. We're going to get the HTTP status OK. We're going to assert that response back. And again, it's just going to run on AWS 100%. And lastly, we're going to check for some unhappy paths. Now, you can't really mock the cloud, right, because it runs on the cloud. But we can control some things like bad input. So if we're going to pass a bad input, I'm missing some, in line 2, the input is missing another parameter. So I want to make sure that I'm going to get a 400 response response code back from our Lambda function. And there are also other important tests that you need to do, such as API security tests. So if you have authentication, authorization enabled, you want to make sure that it's really working. So this is another example of end-to-end tests that you should have. Back to you, Heitor.
Okay, thank you. All right. So you saw the asynchronous part, the API gateway, which you probably have seen it before a few times. But how about the asynchronous part now? We're going to go through the same things, but the asynchronous part. There are certain advices that wouldn't actually work in here. So I'm going to work you through and why that's the case. When it comes to the project part of things, it's exactly as Ron showed you before. We have our domain logic, all of our business logics under domain Lambda handlers, integrations, and such. One of the nice pieces about thinking about asynchronous parts is that for batch processing or events and such, you might want to have a single Lambda handler for one event, another handler for another event, and you can easily separate. By having these folders, it makes it easier for you to see them, what they're for. So nothing changes. The Lambda handler, which is very similar to what Ron actually had, we have a function that's called process string, which is our Lambda handler. But we're going to have to do things very differently now from what Ron did. One thing that not many people actually know you can do this. Lambda function is just a function that the Lambda service will call and say, here's the event, here's the Lambda context. That's it. That's your Lambda function. Everything else, you can extend this function to add defaults, to have dependencies, to have everything you want. And this is what's going to make your test much, much easier. What we do, everything else is the same. We take the event coming from DynamoDB, we use Power Tools to validate everything, and then we're going to use our domain to come up with product changes as it happens. From here, inside, we're only actually converting what's our input from DynamoDB and converting to our domain. So there's nothing really magical in here. It's very simple, no domain logic, if you will. What's interesting about the asynchronous part, which is going to make our testing much easier later, is if it's called by Lambda, it's a real invocation, then this event handler, which is a dependency I will show you soon, it's always going to be none. So in this case, I'm going to create a new dependency and use the event source that this Lambda function is supposed to be sending the event from, and then the event bus. What this allows us is that in the testing later, we can inject this dependency, and we can test the entire code with just one line. And the return notify product updates is essentially our domain. Because it's a very simple product, we're not actually doing any business logic, anything difficult. Our domain looks as simple as we take the dependency, and we simply emit an event based on that domain. That's it, nothing really complicated. We're using dependency inversion to make it easier for tests and to make it easier to add other pieces. Now is an event, maybe it could be S3 later, maybe it could be something else as well, so it's easy to extend. The bulk of this part now is integration. If you think from the integration point of view, you have the input that came from the domain, and then this integration there has to talk to EventBridge. But now we're using EventBridge. What if we want to use SNS later? Or what if we want to use something else as well? That's when things get a bit tricky. So what we do here is that event handler injection that you saw earlier, it's going to have a few responsibilities. One of them is to make it so seamless that you can create event out of anything. We're going to take any Pydantic model and convert into an actual event that we define. And that event, we're going to standardize. If you work in an enterprise company, or if you have multiple events or multiple microservices, one of the easiest ways to make a mistake in asynchronous or event-driven architectures is to simply emit an event without thinking what an event should look like across the entire company, because the more events you add, the more complicated it becomes. It's easy to get lost. So in here, the event handler will be responsible to standardize any event that we create, so it becomes exactly the same everywhere. And for operational pieces, if you're in intro production, you want to think about observability and how do you know when something goes wrong. So event handler will add additional metadata, custom or not, so you know correlation ID. When was it generated? From who? Which version? What if there was a breaking change? So event handler handles all that for us. But you have to send this somewhere. So now we have an event provider that will be responsible to take this event that we just generated and convert into a put events API to EventBridge. So if you later want to switch to SNS, everything else remains exactly the same. Inside this event provider, what we do is some interesting pieces. We know now from this event provider that EventBridge has some limitations on how many events you can send, what's the payload size, and everything else. All this knowledge goes inside this provider. So if I want to swap again, I have a now specific one for SNS or Kafka or whatever else you want to use. And the error handling as well. EventBridge handles error differently. Even if you actually send one event only, or if you send a batch of events, EventBridge will simply say, some of these messages fail. And you have to know how to handle this error handling as well. And last but not least, what makes it possible for you to swap this EventBridge to SNS, Kafka, Momento, you name it, is that we have a contract which whatever event we send, we return a receipt. So now you know which event was successful, which one actually failed, and you can handle these errors better. How does it look like in practice? It looks like this. This is a Pydantic model where we say a product change notification had a product ID, its status, and when it was created, in which we default to UTC. Optionally, we can define the version of our model, which we can V1, V2, you name it. And this is going to become let me go back here, an event. That's our standard event. Every model will become something like this. Inside this event, we're going to have our model inside this key called data, which came from the idea from Lego back in the days. And the metadata is going to come anything else operationally wise, so we can standardize. Whether you use Event Bridge or not, you might already recognize some of these things. What's the event name, the event source, the version, correlation ID. There's a ton more fields in here that we can use. If we ever swap from our Event Bridge to SNS or whatever, you always know that this data is going to look like this. The payload will obviously be different, but if I want to create product change notification now to an event, or I want to create something else, like order change notification, it's going to be exactly the same. Pydantic model in, event out. And then for Event Bridge, at the end, the API will look like this. If you ever use Event Bridge, you already know some of these fields. So we use the metadata and the event standard that we created to fulfill some of these fields, the detail type, what's the data inside, what's the event bus name, etc. Testing this becomes much easier, but we're now going to be using some of these techniques to use more unit tests and then make our integration test easier and convert something that's asynchronous into synchronous. If you remember our Lambda handler, we receive an event handler, and we use this and we pass it on. So we inject a dependency and keep passing until we use it. So if you come from Java or other languages, this is kind of easy for you. What we want to test is that DynamoDB event came in truly, and it was validated correctly. We want to make sure the event handler was created correctly, and we could also take into account the domain event that was also validated as it should. So how do we test this first? Before we test anything, the first thing you should do, which we couldn't call it earlier, is as you start your Lambda function testing, you might have Boto3 or AWS SDK calls, or you import a bunch of these things, and as soon as you run test, it may work locally, it may work slowly, but when you work running CI, it may not pass. Why that is? When you use AWS SDK, we're going to create sessions automatically. And this is a way to, which is also something we do at Amazon and also at open source in general. We want to block any connection outside of our unit test. Unit test shouldn't be calling HTTP endpoints or any sockets at all. So if you add this as a PyTest fixture at the beginning of your code, any test that runs in unit test will automatically fail. So if you import Boto3 initialize clients at the outside of the handler, all these things, which is common practice, it will fail all your tests. And now you know where the side effects are coming from, which makes things so much easier. So it's a plugin called PyTest sockets from Mike. So if you're watching, thanks for doing the work for us. One thing we also can do now, which we couldn't before, is to create a test doubles. Mocks is something we try to avoid at all costs in PowerTools because we have over, I think, 900 tests at the moment. It becomes tricky to have mocks everywhere in some cases. So what we're going to do is, the event handler is a dependency like anything else. We have a contract. So we create a new one called fake event handler, which we can handle everything in memory, which makes it easier for us to assert as well. Inside this event handler, all we can test now, we can say, if we generate the DynamoDB events, we initialize this fake event handler, which I'll show you in a minute, a bit more, and we call our Lambda handler with that dependency already. So there's not going to be any call to Event Bridge or anything at all, because we control everything in here. And what's better is that because we control this fake event handler, we can add Python magic methods or dunder methods to make assertion easier. If we just implement len or contains or equals, our assertion becomes much easier. Inside, all we're doing is we're saying if the number of DynamoDB records should have been emitted from this fake event handler. And just by overriding Python's contracts, we can make this possible. Inside the domain, we want to test our business rule and if it actually uses the integration. The piece that's interesting now about this dependency is that our test just becomes one line. All we're trying to test is that our domain notify product updates is using our fake event handler again, and is actually creating this event receipt that I told you before. The domain should call this integration and return a receipt that an event was successful or failed. Again, there's no I/O here. You can now unit test anything you want very specifically, the entire Lambda handler to domain integration, or simply the domain integration, or simply the integration, which I'll show you now. Now it becomes a bit tricky. We need to test the integration. One of the things you can do before you go crazy on the asynchronous test is to test the contract, that it actually works. One thing I promise you is that we take any Pydantic model and we turn into an event. So we take a simple notification like this, and we simply initialize it. And now the event handler, which I didn't show you all the code inside because it would be too much now, but we're going to give you a link that you can see all the details. We have a method that called build events from model. We pass one or multiple Pydantic models, what the event sources should be, and now we have an event, the standardized event that you saw earlier. And then lastly, we need to convert this into event bridge. So now that we're testing that event bridge creates the put events request as it should, we simply initialize our provider, event bridge, which is hidden in the event handler. If there's no provider, we initialize event bridge. That's how we could swap the SNS and everything without changing any of our code anymore. And then we simply build that put events request, and we can assert that event bridge put request is exactly as it should. And we can look into our event, everything is fully typed, and everything we want. We can even use AWS SDK Stubber to do even more deeper validation. Have we passed the right types? Have we passed the right values and such? Which we also have in our GitHub, which I will show you. That was relatively easy. That's the hard part. And every customer solves this differently. So we wanted to have an opinionated way, but we recently launched another tool, which I'll give you a link as well, to make this even easier. The challenge we have is that once we have an event that's being emitted by Event Bridge, it's lost. We can't really assert anything because it's already gone. We can't really look into it, what was the event that was emitted. We now know that event handler and the Event Bridge provider works exactly as it should, but we don't know if we have permissions to actually send the event or if the event was ever captured by anyone in that case. So the only way to test asynchronous architectures is by introducing something in between. So the way you can do here is by adding additional infrastructure. And we did a little bit more opinionated than usual because I didn't want to maintain more Lambda functions again. And what we did was we created a new rule in Event Bridge to say whenever you see a test event, capture this and store into a DynamoDB table, which we can assert if that event was ever emitted in a shape that we actually wanted. Some people will use WebSockets, which is perfect as well. And in this case, I needed to do that in less than an hour, so that was the quickest solution I could find. And it's also super, super cheap and fast as well. All of this testing takes less than a second. Actually, less than 400 milliseconds, to be more precise. Inside this DynamoDB table, we use the principle of single DB, a single table design, if you like, which we use the name of our test as our primary key. So we always know that the event that was emitted came from this particular test. Otherwise, we have all mixed up. It would be difficult to query. And then we use this issue receipt, so we know that test was emitted, and we can take this exact test from this exact event from this exact issue receipt. Internally, the trick is to use a not very known feature in PyTest called request. If we ever change the name of our test will fail eventually. So what we want to get is dynamically take the name of the test and use as an event source. So now we know every event that was ever generated that came from a test would always have test underscore, because that's how PyTest would actually work. So you can now make it easier for you to have infrastructure in there. I had to build this code, but now last week, like 2 weeks ago, we announced AWS IATK, which is an integrated application testing toolkit, which does this thing for you. But if you're curious on how we did it, we had to do, because there was no tooling, and maybe we do it next year in Power Tools, I don't know, let's see. We created an event fetcher that will handle all this thing about what is the event that was emitted, go to the DynamoDB table, and confirm that was actually in place. Was this 1 event, 2, 10 events? How many failed, and so forth. Okay, let's go into production now and getting close to the end. You saw us talking a lot about Power Tools if you never heard it before. We couldn't show you all the code in the production part because it's a lot of code. It would be difficult for you to see it and to go through. But there's over 100 lines of these things being used in the GitHub, which I will show you. all the data validation, the API routing of one function, one flat function or a micro function if you like, all the batch processing, the secret management, and the more recently, last week we announced open API integration and data validation in one line as well. All of these things is coming from Power Tools. We're using Python as the best language in the world, that's why you're here, but you can also use other languages as well. But the idea is for you to not only choose everything at once, but you can use one feature at a time. That's why it's progressive. So this is to get the code done. But one question everyone asks is that's cool. Every time I add a dependency, how about my code start? How do I even figure out that where my code start is coming from? If you're using PyTorch, if you're using ML, Pandas, or if you're using just normal Pydantic and such, the challenge is for you to know which open source tools can I use before I go to production to make sure it meets my SLA. This is a tiny little tool called Tuna. It's just one environment variable that you can use in Lambda or just locally. It's called Python import time, which Python itself will profile how long it takes to import your code. Everything that imports will be profiled. It generates a very long file. And Tuna, it's an open source project that visualizes all of this as an icicle chart. So you can see where it started, and then it goes all the way down. The deeper, the more calls it had to go through this. So most of the time, the code starts in Python specifically, or the languages as well, is when you import a new dependency. So just by using Tuna, you can easily visualize this. You can call locally, which is what I did here, but you can also use the same in Lambda, and you get the stack trace in CloudWatch logs, and then visualize with Tuna. That's it. One big big difference you're going to see is by running this with 128 megabytes of memory versus 1 gigabyte of memory. The amount of difference could be almost as good as 70% reduction. So visualize it. You cannot improve what you cannot measure. So Tuna is the first one you can use. But this is not good enough yet. We wouldn't go to production with this only. What if we want to know if we want to change to Rust or Golang would actually improve our response times? In this case, it actually wouldn't, not much at least. What you want to learn is we can test through our test how much of our code is being actually used and where we're waiting the most. And more importantly, in this graph, also an icicle chart from PySpy, another open source project, great one, that you can use in production, even on Lambda and containers and such. We want to find where are the most common code path that's being used. And in here, we're testing EventBridge. What you see in purple, if you can read it, is all of the I/O that Boto3 or AWS SDK is just waiting for EventBridge to do something. The TCP connections, the DNS resolutions, and everything. All of this is actually causing this slowness. If we were to switch to Rust or anything, it still needs to await from another networking endpoint to give us a response, so it's not going to change much. But what if we want to go deeper into this? Because this is okay, we can do better. This is another one called PyInstrument. Is my actual favorite now after everything I tried. There's more tools that you can use out there, but PyInstrument is the best visually appealing that you can use. PyInstrument, you can have just a context manager to say, now that I know the most common code path is coming from EventBridge and whatnot, you can isolate in your test or in Lambda function, locally, whatever you want, and that will generate a graph to tell you how long it was waiting the most, where exactly was wasting resources and such, and you can use this as well. If you're more pragmatic, even if you have a good test, there's another tool which is not here, but in the link called PyBenchmark. PyBenchmark takes all these three tools, and you can automate the benchmarking of all these things so you can use in your test. If you look in the Power Tools GitHub, you're going to see that code there as well. All right. 118 slides, right? That's good. When we say about being pragmatic, we also wanted to show you what it is. And we also like to work in public, in Power Tools and Run and open source. We wouldn't be in this open source track if we didn't bring you anything in open source. Just talking about use case is nice, but actually showing you the code is actually the piece that gets me more interested as an attendee as well. We're still documenting it, to be honest, all of the decisions we made. Why did you choose CDK? Why did we do some hacks in the build process? Because we had to. The tools are not actually exactly as I wish we were back then as well. And we also documented the integration pieces, the API documentation, and even give you the tools that we used under the hood. All these open source projects out there as well. Don't worry if you missed the QR code. There's going to be another one, which is the treat for you. So don't worry, relax. the Vegas climate. Okay. In summary, we showed you 5 pillars to make it easier to review any application that you have, existing or building a new one, or something you're going to be modernizing it. If you think from a project is how do you structure that so it's easier to onboard new people so they can see how things are organized. The handler, all it needs to do is to take whatever event and convert it into a domain or business logic, nothing else. If you do more than this, it's very difficult to manage that later. But you don't have to either. It could be just a single file for something simple too. The domain, all the business logic, the integration, like we mentioned, and then the testing. If you take this into account, when reviewing your code, it's going to be easier to have a conversation, more pragmatic conversations with your peers and your teams. If you are interested in knowing everything we couldn't cover, and everything I wish we could go even deeper into explaining the code and go to a 400 type of level session, this is all the links. But there's also something extra that Ron did for you that I hope you're going to love it. Building all these folder structures and all this testing, all these interfaces takes time. There's a template right there that you can do in one click or one CLI command line that builds an entire project with all these practices already in for you to be actual proper open source for you as well. And we're also going to add it tomorrow, the slides for this as well. So keep that QR code close to you. I'll wait for a few people and then I will close it off. Okay, all right. One last person, and then we go. Cool. If you want to continue this conversation, or if you want to show us some of what you have, or how do you optimize your code, or some of those pieces, obviously I can't type the code for you, but I can definitely tell you, don't do this ever. Come find me specifically. Maybe Ron will be there, I don't know. We have a booth at the Venetian at the very center, where all the open source experts will be there. So I'm bringing my whole team as well, not just Python, so TypeScript people, Java, and .NET will be there too, if you're interested to continue that conversation. And please don't forget to use the survey. This was one of the rare sessions that it took a while to get it approved. We wanted to go to this session for every language and to be more pragmatic on the tools you can use for Python, for Java, or for TypeScript. So please help us with the review, and then hopefully next year we can go even deeper into these topics and bring other languages as well. I was Eitor Lessa, Chief Architect for Power Tools for AWS Lambda. I hope you enjoyed with my friend Bran from CyberArk. Thanks for coming.